To lesson 10.1.1. If you're watching this during the coronavirus epidemic, then you might have already done this with the extra credit assignment. However, if you're watching it after that, then I don't know, I guess we did this lesson. So long story short, some of you maybe have already seen this, maybe some of you guys haven't, but I decided to make a video of it anyway. What is the equation? The equation of a circle. In chapter 8, you studied circles geometrically. That is, based on the geometric definition of a circle, the relationship between circles and polygons helped you develop methods to calculate the area and circumference of a circle. And you extended those methods to calculate the areas of sectors and the lengths of arcs. How can circles be represented algebraically or graphically? And how can you use these representations to learn more about circles? Today, your team will develop the equation of a circle. The equation of a circle. You have studied equations of lines, exponential functions, and parabolas, but what type of equation could represent a circle? On a piece of paper, draw the set of xy axes, then use a compass to construct a circle with a radius of 10, centered at the origin. Explore with the 10.1 student e-tool. I went ahead and popped that e-tool up. You can see in this example, I do have a radius of 10. It's at origin, the center's at origin with a radius of 10. So that's essentially what it asked me to do. Obviously, I did not use a compass to do it. So it says, what do all the points on the circle have in common? That is, what is true about every point on the circle? Well, if you go here, you'll notice that this is 10 away, that this is 10 away, that this is 10 away, and that this is 10 away. And you kind of have to assume that that would be true the whole way, that this radius would always be 10. I mean, if the radius is 10 here, then it must be 10 here. That just stands to reason. So I would say that they're all 10 away. They're all 10 from the center of the circle. So determine all the points on the circle where x equals 6. For each point, what is the y value? Again, I'll run back over here and we'll see that when I'm at 6, it looks like my y value is 8 or my y value is negative 8. So when my x value is 6, I either get 6, 8, and I get 6, negative 8. I actually have two outputs there. It says use a right triangle like the one shown at right to justify your answer. Well, it would make sense to me that I would have, if I had 6 here and 8 here, that it must be 6 squared plus 8 squared is equal to 10 squared. And that works. 36 plus 64 does equal 100. If I change this to 6, negative 8, that wouldn't really change anything. I still have that right triangle, so I can still say 6 squared plus negative 8 squared should equal 10 squared. And just what we know about negatives, that will still turn positive. I'll still get 36 plus 64 equals to 100. So we were able to check that. On C, it says, what if x equals 3? What are the outputs when x equals 3? Well, I went ahead and did this earlier because it was kind of a pain to get it exactly. But you get 3, 9.5, and you would also get 3, I'm not sure if I can get it exactly. You can see why I left it last time. You get 3, negative 9.5. So I get 3, 9.5, and I get 3, negative 9.5. And same thing, the Pythagorean theorem should justify that this equals 10. I don't think it's going to be exactly 10. There's some rounding there, so we'll see if it ends up hitting it on the dot or not. But so 3 squared plus, 9.5 squared should be, I'm falling apart here. Oh boy. 3 squared plus 9.5 squared should equal pretty close to 100. And you can see rounding did take place there. That's roughly 100, so there was some rounding. Obviously, negative 9.5 will be the same thing, so we did justify using the Pythagorean theorem that this is true. Now we have D. It says, Mia picks a random point on the circle and labels it X or Y. So we have this point XY. Help her write the equation of x, y, and 10 based on diagram above. Well, if we just call this xy, this point is xy. That makes sense, right? Over x up y. So it would seem to me that we could say that x squared, this squared, plus this squared would equal this squared, because we have that right triangle. So you can see, I think it's kind of interesting we talk about triangles making up so many shapes, and I always have a kid say, what about circles? Well, here we are. We have a triangle making up a circle, which is kind of interesting. It says, does your equation from part D work for point 10, 0? Well, let's see. 10, 0 should be 10 squared plus 0 squared should equal 10 squared, which it does. What about 0, 10? I should get, again, 0, 10's right here. 0 squared plus 10 squared should equal 10 squared, so of course that works. What about negative 8, negative 6 down here somewhere? Well, negative 8 squared plus negative 6 squared should equal 10 squared, and we get 64 plus 36 does equal 100. So that worked for all of those. So yeah, that Pythagorean theorem, those right triangles, definitely work. 10.2, in problem 10.1, you wrote an equation of a circle with a radius of 10 and a circle and a center of 0, 0. What if another circle has a center of 0, 0 but with a radius of 4 instead? Discuss with your team and write the equation of the circle. Well, I would think, and I'm not sure how easy this will be to open, I would think that we could draw a circle starting at the middle. Well, it didn't work. I guess we'd start at about 4. And we go to 4, and we go up 4. Again, that didn't work. Maybe something like this. That's much better. Okay, so here we have a radius of 4, you can see. And again, if we're going to go with those slope triangles, it looks like we'll just call this point xy, and this is 4. It looks like we can say x squared plus y squared is equal to 4 squared. So that seems to be an equation we can go with. X squared plus y squared equals whatever the radius is squared, right? If that radius changes, then we'll change that there. Let's see if this will reopen. I suspect it will not. Oh, no, it did. Happy surprise. So if we go down to 10.2, problem 1, A, it says if we have a center of 0, 0 but a radius of 4, we'll just say, well, it's x squared plus y squared is equal to 4 squared. Write the equation of a circle with center 0, 0 and a radius of r. Well, again, like we said, whatever that radius is appears to get squared because we have that slope triangle, the Pythagorean theorem on that. On graph paper, sketch x squared plus y squared equals 36. Can you graph it without a table? Explain your method. Well, yeah, I think if we go back over here, I don't know if I want to open this. This is going to be a pain. It's probably not going to work. We were at -6, -6. Oh, I need to change this to a circle. Huh, did I miss something up there? Oh, there we go. Okay, so in this one you can see that we're going to get something that looks like this. Right? The graphing it isn't that difficult. We know we have a radius of 6. I can go to here, put a 6, 6, 6, and 6, and then just sort of round out that circle. That's going to be x squared plus y squared equals the radius squared. So we graph that. Like I said, we just assumed it had a radius of 6, and it did. We'll just take the square root of that to get that. And describe the circle that's x squared plus y squared equals 0 squared, where it goes here and it moves none. So we just sort of get that point. It's really a circle with the center 0, 0 with a radius of 0, right? The square root of 0 is 0, so it doesn't really change right there. Let's go ahead and jump to problem 10.3. Yeah, that's not going to work here. So we will reopen it. Alrighty, so 10.3 says, what if the center of a circle is not 0, 0? On graph paper, construct a circle with center of 3, 1, which we have right here, center of 3, 1 with the radius of 5. It says in the diagram right, point P represents a point on the circle. So it's any point on the circle we just randomly called XY. Add a point P to your diagram and then draw a triangle ABP so you can see this has all been done for me. B said, what is the length of PB? Well, the length of PB is interesting. It's whatever y is. Remember, this goes over x and up y. So this is a distance of y right here. But you can see I've already taken 1 out of it. So PB has a distance of y minus 1. And likewise, AB does something similar, just in a different direction. It has a distance of x, but here we've lopped 3 of that off, right? So I hope you can visualize what it is that we're talking about here. Essentially what we're saying is this whole distance is y, right? But I don't have this whole distance. I have 1 less than this whole distance. And this whole distance is x, but I don't have this whole distance. I have 3 less than x. So it says use your expressions for AB and PB and the fact that the center of the radius is 5 and write the equation. Well, it's this squared. This is distance. Whatever x minus 3 squared plus whatever y minus 1 squared should be equal to 5 squared. So now we've written the equation of a circle when the center isn't at origin or isn't 0, 0. So now when we go to D, it's going to ask us to just write the equations of these circles that we see here. So here we have a circle with a center of 2 and 7 and a radius of 1. Well, pretty simple. I'll just say x minus 2 squared plus y minus 7 squared is equal to the radius squared. And if I go to 2, you can see I have a center at 3, 3. So my center is at 3, 3. So I'll say x minus 3 squared plus y minus 3 squared, and that's going to be equal to the radius of 2 squared. What about 3? 3 may help to have a little bit of a graph here. So we have a point at 5, 0 and a point at negative 5, 0, and we know these are endpoints of a diameter, so we know the circle does something way curvier than that, but that's essentially what it does. So we have a center at 0, 0, so we'll just say x squared plus y squared. You could say x minus 0 squared and y minus 0 squared. It wouldn't matter, but we appear to have a radius of 5. So we'll say 5 squared. Again, we only want the radius. We don't want the entire diameter. And finally, 4 is a little bit tricky. We're going to go in a different direction this one. So now, again, just imagine that we had picked this point. We know that the x direction would be here. So we have the whole x, but we have this minus 2. But we can't say x minus 2. We actually have to add 2 to it. Whatever this distance is, we have to add 2 because this is at minus 2, right? So we have to add 2 just to get back to 0. So we're actually going to say x plus 2 squared here. Again, it's kind of interesting to visualize, but this is subtracting 2 from whatever the distance of x is. So I need to add that 2 back in. But in this direction, it's just y minus 1. So it's kind of the opposite of what's going on there. We've dealt with that a lot with parabolas. I hope you guys are able to visualize that. The radius is 1, 2, 3, so we'll say it equals 3 squared. So we have the equations of the circle. At this point, if you are in the age of coronavirus, you can definitely skip problem 10.4. We skipped some stuff in chapter 9, unfortunately, as we ran out of time at the end of the year. So you did not need to follow this if it is Corona year, but if it is not Corona year and you're just missed school or something or we're struggling and watching this video, you should definitely stick around for 10.4. So on graph paper, sketch the graph with the equation shown below. So we have y equals x plus 2, and we have x plus 2 squared and y plus 3 squared equals 9. So it asks us to graph this, so that's fine. We'll go ahead and we will take care of that. I'm not sure what would be, I think Desmos would make this way easier. So I'm going to go to Desmos. I just don't think if I put this on a chart, I'm going to have a lot of luck drawing that circle. The other ones I could do because it was at origin, but I don't think it'll be as easy. So x plus 2, I get this line, and x plus 2 squared plus y plus 3 squared is going to equal 9, which is really 3 squared. I mean, I could just call it 3 squared. I think that would be an easier way. We can see that has a radius of 3. Obviously, that equals 9. So we have a center at -2, -3, -2, -3. You can see it right there with a radius of 3 in all directions. So we have some points of intersection here, but I suspect it wants us to do this algebraically like we did in chapter 9. So let's jump back over here. It says solve for the intersection using an algebraic method. So there's a couple things I can do here. There's a slightly easier way to do this than the way I'm going to do it, but I think the easiest thing is just to visualize. I already have y by itself, so I'm just going to go here and I'm going to substitute out. So I have x plus 2 squared plus, well, y is the same as x plus 2, so I'll change that y to x plus 2, plus I had a plus 3 squared equals 9. So when I solve this, I'm going to get, now if you think about this, I have an area model, x plus 2, x plus 2. So this is going to turn into x squared plus 4x plus 4. Likewise, this is simply x plus 5 squared. So I can go here and do my area model of x plus 5. And I'm going to get x squared plus 10x plus 25 is equal to 9. So when I add these up, I get 2x squared plus 14x. You can see I have plus 29, but I need to subtract 9, so 29 minus 9 is 20. I'm going to factor out a 2. So hopefully you guys remember that from earlier in the year. And now I can just use the diamond, hopefully. So I have 10 and 7 with ax, 1x there. So I go 5 and 2. 5 times 2 is 10, 5 plus 2 is 7. So I get this equation, y equals 2, x plus 5, x plus 2. But again, I want the intersections of these. So I know my solution here will be x equals -5. And I know my solution here will be x equals -2. Well, I could plug those into here and solve for y, but you can see that's going to be a pain because y is not by itself. What would be easier is to plug it in here. -5 plus 2 is -3. So I get this ordered pair. X is -5 and y is -3. And then when I plug in -2, -2 plus 2 is 0. I get y equals 0. Now, what I should do is I should substitute them in here and check. I could substitute in just the x and solve for the y, but I think what would be easier is substituting them both in at the same time and seeing if they equal 9. And here's what I mean. If I substitute in a -5 plus 2 squared plus a -3 plus 3 squared, does it equal 9? Well, here I get -3 squared, which is 9, plus 0 squared, which is 0, equals 9. So that did work. So that was a pretty easy check. Now what I'll do is I will make a little bit of room and do the same thing with -2, 0. So if I plug in -2 and 0 for the y, I get 0 squared, which is 0, plus 3 squared, which is 9, is equal to 9. So you can see that both of these were the correct solutions. So that's how I know that I'm right. I can run over to Desmos and confirm that fact, that I have my -2, 0, my -5, -3. I hope that made sense. Have a good day.